Kia ora koutou katoa, it's Mrs. Goodson here, and this is a video about writing a method for a science investigation. And it applies to actually all science investigations that we do, but it's aimed at my level 1 classes who are doing investigation into either biology and respiration or into chemistry or physics. Okay, so what is a method? It is a step-by-step instructions on how to carry out the experiment. So it must include what is going to be changed. The one thing we're going to change, remember that's called the independent variable. How will it be changed? And it must have a suitable range. Now you see, need about 3 or 4 different data points in your range, from the smallest to biggest, and you need to spread it out as much as you can depending on your experiment. So the dependent variable is the thing you're going to measure. How are you going to measure it? What equipment are you going to use? How are you going to make sure that the measurements are really accurate? And what are you going to keep the same? What are the control variables? What are the things that might affect the results? You want to have at least 3 or 4, but just have a really careful think about how the experiment might be affected by different things. Think about how you could affect these things could affect your experiment. And in your discussion, you will talk about how you controlled these and you improved the accuracy and validity of your experiment. Um, Depending on what your experiment is, you might need to also consider at least 2 factors such as sampling bias and other sources of error, and how you're going to minimize sources of error in your method. Sampling bias refers to the fact that are you going to take a random sample? How do you know that the sampling that you do is representative of the population that you are trying to investigate? For example, if you use one person in your team to um, do the experiment, are they representative of uh, the population, or is it human beings you're trying to investigate? Is it year 11 students? Is it something? So sampling refers to um, that you can't test the whole population, so you just take a sample, and is that sample representative, and can you rely on that sampling? And in our earlier video, we talked about reliability. And so we want to do our experiment at least 3 times and take the average so that we can trust the results. So we need to build the repeats. And now this is an example method. So take resting pulse for 30 seconds, multiply the result by 2, record in the table, repeat 3 times. Do star jumps for 10 seconds. Can we be more accurate about the intensity of the star jumps? Should you do one jump every 2 seconds? Or are you just going to rely on the person to make sure the star jumps are the same each time? Take your pulse. Is the person good at taking their pulse? If we had the right equipment, is there a better way to record their pulse? Or is this taking your pulse with your fingers on your wrist? Is that going to be accurate enough? Resting. Now, this is really important because after each trial, the person's heart rate is going to be elevated. It's going to be quite high. So it would affect the results. If we just did each trial one after the other, their heart rate would go up, but up and up and up. So we need to think about whether that would be a fair test or not. So the resting in between the trials is really important. And then we're going to repeat the steps for the different amounts of time. So there's different things we can test when we're thinking about exercise. We can test how long they do it, which is the duration, the amounts of time. We can also change the intensity. We could do the star jumps faster. We could do different types of exercise. So we could have someone walking and then jogging and then sprinting. So just think about how you're going to change your independent variable and just exactly what it is. Is it duration? Is it intensity? Is it type of exercise? What is it that's actually being changed? And then in step 6, we repeat steps 2 to 5 3 times. So that's just for getting the reliability. going. So what makes a good method? It's got to have nice, simple instructions, easy to understand. It's got to have lots of details. It's got to have the repeats included. It's got how to change the independent variable, how to measure the dependent variable accurately, and how do you make it accurate, and how to control the control variables so that it is a fair test. So this video has been about how to write a step-by-step method that another student could easily follow that includes changing the independent variable and how many trials to repeat.